lesson is on solving systems by elimination using multiplication. Let's solve the system 2x minus 3y equals negative 11 and 3x plus 2y equals 29 by elimination. Remember, your ultimate goal in elimination is to create coefficients that are opposites of each other. Right now, we don't have opposite coefficients. On x, our coefficients are 2 and 3, and on y, our coefficients are negative 3 and 2. We don't have opposites. So what we're going to do is use multiplication to create opposites. Now, it doesn't matter which variable you choose to eliminate. If you have a coefficient of 1, it does simplify the process, and we don't have a coefficient of 1 in this system. But if you look at your y's, their signs are opposites. One's negative and one's positive. So for that reason, I'm going to choose to eliminate my y's. Now if I look at the coefficients, negative 3 and 2, I notice that both of those numbers go into 6. So I'm going to try and create a coefficient of negative 6 on y and a coefficient of positive 6 on y through multiplication. So to get the negative 6 out of the first equation, I'm going to take the existing negative 3 and multiply it times positive 2. But that means I have to multiply everything by 2. So 2 times 2x will create 4x. 2 times negative 3y will create a negative 6y. And 2 times the negative 11 creates a negative 22. Now we're going to use multiplication to create the positive 6y out of the second equation. So I'm going to take the existing positive 2 and multiply it times positive 3. But that means I'm going to multiply everything by 3. So 3 times 3x gives me 9x. 3 times 2y creates a positive 6y. And 3 times 29 is 87. So now that I've created opposite coefficients on y, I'm ready to add to solve this equation. So 4x plus 9x gives me 13x. Negative 6y and 6y add up to be 0, so the y's are eliminated. And negative 22 plus 87 gives me 65. Dividing both sides by 13, I get that x is 5. So now we'll substitute that into either original equation. I'll pick the first one and solve for y. So 2x minus 3y equals negative 11. I'm going to substitute that x is 5 and start solving for y. So 2 times 5 is 10. To undo the 10, we're going to subtract 10 from both sides. That gives me negative 3y equals negative 21. And then I'll divide both sides by negative 3, and that gives me y to be positive 7. So it appears like our solution will have an x-coordinate of 5 and a y-coordinate of 7. But we can test that solution in the second equation. 3x plus 2y equals 29. So plugging 5 in for x and 7 in for y, we get 15 plus 14 equals 29, and 15 plus 14 does give us 29 equal to 29. That is a true statement, so it checks out, and our solution to this system is 5, 7.